Okay, so yeah, thank you very much for the invitation. First of all, nice to meet you all. I think it was a long day for everyone, so I try to keep it short and try to be catchy somehow. But I really appreciated the previous two presentations. I would like to discuss for hours, but yeah. I decided to bring here a more, let's say, theoretical approach, and based on two main topics that, in my opinion, are interacting with the concept of adaptive transformation, and they are the surface use optimization and the circularity. And I will mainly focus on urban space rather than on buildings, because I'm more familiar with it and I'm more comfortable with that. And is the topic I work most. So definitely, we are definitely facing a lot of challenges, and I completely agree what has been said before, that adaptive transformation or reuse, adaptive use is one of the solutions that we can apply to our cities, that are the place where we mainly live. The urbanization trends is growing and growing, now in Europe we are mainly living in cities where the most of the activities are taking place. This is also why we are experimenting there more vulnerabilities and in general exposure and to climate risks, but not only, also in the last month. Unfortunately, we are also experiencing other risks, mainly energy crisis. So cities have to be redesigned, rewritten. I start with the first concept that I would like to bring to the table of the discussion: the surface. Till today, and usually I see with the discussion with the municipalities where we are working with, I see urban surfaces treated as a cost, a cost of pavement, a cost of painting, a cost of even maintaining the green, and the specific concept of surface is not even recognized as the focus of the work. We call it land, we call it space, but in fact we have to interact with something which is a surface. And this surface, and this is the hypothesis, can be transformed from a cost to an opportunity, which is linked to many functions that are potentially there but are not yet unlocked. And so how to optimize the urban surface use, promoting this adaptive transformation of urban spaces, is the key question that we have to face. Let's start, and in fact, I was mentioning the fact that the surface is not the focus of many of the tools and instruments that we have at the moment in urban planning. What is the surface in the city? There's a ground surface, of course, so open spaces, streets, as has been mentioned already, but it's also the vertical facade of a building, and is also the roof. So everything that is, covering the city is a surface. And it's quite curious that we will get there later, but we are planning only this 2-dimension. There is a unexpected exploitation potential of urban surface, and only the roof has been estimated at accounting for around 20-25% of the total urban surface, and the vertical facade even the double. So what benefits can be unlocked if we are starting optimizing the use of the surface in a systemic integrated way? Of course, we can look at the current challenges that was mentioned before and provide additional or more effective and efficient services to citizens, improving the reliability, but in general terms, the quality, the resilience, the self-reliance of a city. So we can definitely look at the surface as an opportunity to tackle climate change and manage the urban climate, to improve and empower the habitats and biodiversity, manage the water, improve the air quality, produce energy, storage fresh water, or produce food. Of course, these potentials are already somehow followed by a number of solutions that we have in our laboratories, and we are starting implementing with mainly pilot projects in cities. But what is actually lacking is a systemic approach that is embracing the city as a whole, selecting case by case, but in an integrated and systemic way, the right solutions. At the moment, what I see is mainly plots that are somehow designed with some of these solutions that are not interacting with the surrounding plots. And so they are creating somehow highlands or a very scattered approach to this adaptive redesigning of the city. And it is also creating conflicts instead of potential integrations. And these metrics show you in general what could be the interaction between different uses and solutions using the same surface. In some cases, we might have synergies and integrations. In other cases, we might have conflicts. What is absolutely lacking is a governance scheme. Who decides if in a roof is better to put a green roof or a solar panel from, let's say, the improvement of the overall condition of the city? No one. No. So we still have very single solutions applied to single cases, and very few examples of integrations, and very few examples of instruments that are able to drive the transformation, adaptive transformation of the entire city. And as I was mentioning before, we have a two-dimensional mindset. Unfortunately, in planning schools, for decades and from the beginning, we use flat papers and maps to design our master plans. The codes, the master plans are focusing on plots, and the building regulations considers the height limits, but not the active use and potential of vertical surfaces. There is nothing apart from the colors of the buildings that are ruled for the moment. There are very few cases like the Bioto area factor in Berlin somehow, or the green area factor in Seattle, but really there is a lack of this instrument that are able to embrace all the possibilities that the surface can host. While our vertical surface is counting for about 80% of the total surface now in comparison to the horizontal one, especially when there is high density cities and urban environments. So just think about what could be the disruptive change if we start thinking and planning in a multidimensional way instead of 2 dimensions. As for multi-dimension, I don't only mean the 3rd dimension, but also the time, the economy, the social dimensions, and the governance dimensions. I bring you some examples. We are still at the beginning of the debate at the International Energy Agency. Now we are starting up the TCP cities, which is finally embracing the city as a specific focus, and there are a number of interesting tasks that are starting up in these years, and a number of tools and instruments will be developed. For sure, we can account of models that are able to tackle the 3rd dimension. Of course, they are very heavy and need a lot of data, but are able somehow start modeling. Usually they are not able to model entire city, but only small districts because of this limitation that we have. But we are perhaps in the right direction. This is for greening, but also for microclimate, and they are able also to produce scenarios for changing the materials, including new vegetation, and see what is the effect. I can mention EnviMet as a commercial tool, but also Plan for You, which is an open source developed by TU Berlin. Which is a very powerful tool. I would also give you a reference. This is a report I co-authored, the survey uses in solar neighborhoods, coming from Sustainability and Cooling Task 63, where we collected a number of sheets that can suggest, the potential interaction between different uses of the surfaces in cities, showing reporting what is the solution, what are the suitable surfaces, the benefits, and with some examples. The second concept that I would like to touch today is the circularity, and mainly related to the trend of refurbishment of existing buildings, and this I'm going to report you the results of the study that we did for the province of Bolzano, because of course, as many other areas in Italy and in Europe, is facing a trend of refurbishment of existing buildings. So let's say the market here, and we had a lot of incentives in the last year in Italy called super bonus 110 and whatever. But this unlocked a big market for the energy refurbishment of buildings, that provoked somehow a flow of materials and waste that is connected to the construction and demolition sector. So the question that we pose to the territory where we are placed in North Italy, we are in a small city called Bolzano, which is in the heart of the Alps, close to Austria. But the question was, can we think about closing the loop somehow and using connecting the built environment to the bioeconomy, which is a very important sector as well in the province. And yeah, so we found that there is a large room for improvement in the concept of circular economy, especially in construction demolition, because it accounts for a large volume of waste. And yeah, and there is also a very big potential in the bioeconomy, especially in agriculture and forestry sector, to be connected to this sector of construction demolition. Generally speaking, we define a flow concept that is putting the built environment at the center, and then is taking the, let's say, waste and bioproducts, and byproducts from forestry and agriculture, injecting the built environment, preventing waste and managing it, and so re-injecting in the circle. First of all, we had to map the residual biomass in the province, and then we ran the material flow analysis on the construction demolition sector, understanding then from where and which kind of material these materials are coming from. So we consider different type of materials that are used in the construction demolition sector. And then we define a scenario, which is of course a first scenario. We are still working on this, but is an hypothesis that we need. What if we substitute the traditional insulation material EPS with wood fiber coming from byproducts from the forestry and agriculture? What does it mean in terms of avoided primary energy non-renewable and greenhouse gas emissions avoided? And this is the result, which explains that if we are able to, well, there are a lot of assumptions, of course, but for example, that we can substitute the EPS with 50 kilograms of wood chips every 1 cubic meter of wood fiber, substitute the EPS. And that 50% of the residual waste from agriculture and forestry is available for this kind of use. But the results are quite interesting, because what came out is that we could substitute up to 50% of we can avoid the use of up to 46% of non-renewable energy and avoid up to 50% of greenhouse gas emissions, which is equal to a total of 2,390 tons of CO2 equivalents per year. The good news is that these tons of CO2 remains captured in the building stock, which is a potential strategy for carbon capture and sequestration. So in general terms, we might also not only reuse the waste, but also store the CO2 in the building stock. And with this, I close my presentation with these two inputs for the discussion. Thank you very much.